Hey guys, good, good, happy Sunday, everyone. Just confirm, please, can you hear me? You can just, if you don't talk, if you don't want to talk, you can just react if you can hear me, so I can know if I'm audible. All right, great, great, great. Yeah, so, I mean, it's nice to be here with everyone. So, let's just continue from where we stopped in the last class, right? So, for those that are just joining us for the first time, we've talked about, this is about Web3, and we've covered, a couple of things, like the blockchain, what it is. We've covered cryptocurrencies. We've covered, the types of cryptocurrencies we have. We've created a wallet and, shown how to interact with wallet as well, right? We've discussed about transaction and gas and what's it called, and smart contracts, right? So, I mean, this being the third class, we are more like almost, wrapping up with things, right? So the things we have left is just briefly discussing about layer one and layer two and what that is, and then we're going to practicalize and we're going to build a smart contract today and deploy it on the Sepolia Ethereum blockchain, right? So I think it's going to be handy a bit. So let's just get started, right? So uh, just for, let me just highlight this. Can you see my screen? Okay. I think I'm just sharing the tab. Let me stop sharing and reshare my screen again. Okay. Entire screen. Yeah, share. Okay, guys. So you should be able to see my screen now, right? So today we're going to talk about layer one and layer two, and then develop a smart contracts, right? And we'll talk about, roadmaps to different careers in Web3. So now, continue from our last class. So layer one and layer two. Yeah, so layer one is actually a, a blockchain like Ethereum, for instance, right? Why layer two is a blockchain inside another blockchain. So, you can picture it like, okay, Ethereum, which is a layer one blockchain, which is the main blockchain that keeps record of transactions, and then, smart contracts can be built in the Ethereum blockchain and, deployed on the Ethereum blockchain. And then, other projects as well can, be built in the Ethereum blockchain, you get. So, with that being said, layer one blockchains are like the Bitcoin blockchain, which is a layer one. We have the Ethereum blockchain, which is a layer one as well. We also have Solana blockchain, it's also a layer one blockchain. There are a lot of layer one blockchains here. So anytime you hear layer one blockchain, just know that it's like the main blockchain you get. Then we now have layer two, right? So layer two was created to, in a way, kind of solve scalability issue with layer one, right? So, I mean, it's one of the mechanisms that they, implemented when they were trying to like find a way to scale layer one blockchains, you get. So layer two came in as a result of, I mean, it's one of the things that it came in to do, try and come and fix the scalability problem in Ethereum. For instance, in Ethereum now, um, we have a layer two blockchain. We have a lot of layer two blockchain, but one of them is like Optimism, right? So Optimism is a blockchain built inside of Ethereum blockchain, right? So what's it called? One of the major, problem with Ethereum or the Ethereum blockchain is the high gas fee you get, high cost of transaction, and the gas fees you get. They can be very, very high, unreasonably high, you get. So layer two was created as one of the reasons why layer two was created in the Ethereum blockchain is come and solve this, scalability problem of, okay, you know what, let's still, let's build something on Ethereum that sort of just reduces the gas fee. What's it called? The abstract that gas fee, problem you get. So it doesn't necessarily solve the gas fee problem on Ethereum blockchain itself. What it does is that it creates alternatives for people to still build on Ethereum blockchain, but on a different blockchain, but still inside Ethereum. So, with that being said, yeah, um, anywhere you hear layer one and layer two, I think the one of the sweetest explanation is just remember Nigeria, right? Nigeria is a layer one, is a is a country, is a place where we live, right? And then you can now when you hear layer two, you can think of states in Nigeria like Abuja, like Lagos, and the rest of the 34 other states you get. So I think that's the perfect explanation, being that Nigeria, best in this context, this Nigeria is a blockchain here. Nigeria is a blockchain, right? And inside of it, it has, you know, a landmass. Then it has different states like Lagos, Abuja, Ibadan, and a lot of places like that. You get. So now, inside of, for instance, now Lagos is built inside of Nigeria, right? Just it's just the same way Optimism is built inside Ethereum, which Optimism is a layer two and Ethereum is a layer one, right? So, I mean, with that kind of analogy, I think we can be able to, identify layer ones and layer two, right? So, so yeah, guys, any questions so far? Any questions? Okay, so I want to believe at least we sort of understood, or in a way, kind of understood what has been said, right? Uh, so yeah, um, so I think that brings us to the end of what's it called? The basic intro about the blockchain and about Web3, right? So now having learned, all these things, for those that are just joining us, you can check out the other previous tutorials on the Brightflare Academy YouTube channel. You could just type uh, Web3 class Brightflare Academy. You're gonna see all the videos of the classes we have had, right? So today we're going to be primarily deploying a smart contract, right? So we talked about smart contract being executable codes that are stored on the blockchain, right? And they trigger certain things when certain conditions are met, right? So having said all that, theoretically, let's just build one, right? So today we'll be building like what's it called? We're building a faucet system, right? So where what's it called? Where users can sort of like deposit into the smart contracts and also withdraw from the smart contracts, right? And then one of the features, okay, how it works is, number one, users can fund the faucets, right? Users or owners or the contract owner, right? When we're deploying a smart contract, for every smart contract deployed, there must be an owner for it, you get, and the owner is usually the wallet that deploys that smart contract, which we're going to see later, like very soon rather, right? So in this smart contract that we're developing here, you know, there's two type of users here. We have the normal users, which is everybody, and then we have the owner, which is the owner of the smart contract, right? So in this sense, it's going to be me basically or my wallet because I am the one that would be building this, and then we'll be deploying it on the Sepolia Ethereum blockchain, which is a blockchain to sort of you know, simulate how to build on the main Ethereum blockchain here. So you can just picture Sepolia Ethereum blockchain as a test blockchain. You get. So one of the three, I mean, there are going to be some functions we'll be writing here. And by the way, before we dive into this, let me just say something here. So one of the prerequisites we're going to need for this is to learn Solidity, right? But because of the limitation we have, I think the best way is to just you guys should just sort of follow along, and by the end of today, I'm going to recommend some very very helpful what's it called some very, very helpful sites that we could go and learn. Basically everything from blockchain basics to, how to understand Solidity code, how to write Solidity code to beat your smart contract, and, even how to, audit smart contracts as well, right? And then earn and then, you know, learn as well, you get. So maybe, towards the end of the class, right? So let's just go into what we need to do today, right? So let me head over to my browser, right? And then let me find a way to collapse this. Okay, so today we'll be talking about, okay, sorry. So we're going, we would head over to remix.ethereum, right? Let me type that again. Okay, yeah. So remix.ethereum, or simply just type remix IDE on Google, right? And let me just reload. So let's type remix ID. Yeah, so we would have seen it remix ethereum.organization or remix ethereum.org, right? So that's the first thing that will pop up, and then we'll click on it. So what is this here? So this is an IDE, and an IDE simply means integrated development environment, right? Which simply means a place we can write codes. Yeah. So yeah, we're using Remix, right? We could also use VS Code to write our codes. You get, right? This is VS Code here, which basically still does the same thing as Remix, but it's just that it does it at a bigger scale, and it is much more professional to write your codes and store them or structure them with VS Code as well. You get. So, but because we're going to be doing today is just basic, right? We'll be using Remix, right? And let's continue. So because we're creating a smart contract, and smart contract are basically instructions or just coded functions that triggers when certain conditions are met. So when we come on remix.ide or this site, the first thing we're going to do is to come to the contract folder, right? And then, okay, this is because I've developed something here, but then let's just delete all that is here rather. Okay, so by default, when you create this, when you come on remix.ethereum, right, by default, you see, when you click on this contract folder, you see about three different, what's it called? Three different contracts, right? So you can just do with them, you can just delete them and start afresh, you get. So what we're going to be doing next is we're going to hover around the contracts folder, and then we're going to create new file inside that folder. So the file we're going to be creating will be our file sets, right? Our smart contracts we're going to be developing. So let's just name it. Let's go for a simple name, file sets, right? Dot sol. So why do we have this dot sol extension is because we're going to be writing our smart contract and building it with Solidity. So for any Solidity is actually a programming language, right? And um, I'm going to refer everybody to Cypher Updraft, which is a place you can basically learn what's it called? A place where you can learn blockchain basics. You can learn how to build smart contract with Solidity as well, right? But after we deploy this thing, I'm going to I'm going to show you sites, and it's a very nice place to learn. That's where I learned. That's where I learned what's it called? You know um, how to build smart contract. That's why it really learns everything about blockchain. So it's a very helpful site. I mean, everybody should even learn it, right? Um, so let's continue here. So like I said, we created our file name. We said it's file sets here, and then add this dot solidity extension, which is dot sol in short here. And then we click on OK, or enter, right? So it's going to bring us into this environment, a place where we can write our codes here. So, are we following so far? Like, am I audible? Just to confirm, is everybody
Yeah,
following?
yeah.
Okay, all right, great. So, So let me just say this in advance because what's it called? Maybe I think after 45 minutes, this meeting would end. You get because I'm using a free plan on Zoom, right? So once it ends, you can just rejoin back with the same link, right? So I'm going to auto start the meeting again. So we'll continue from where we stop. So yeah, so let's continue. Yeah, so I mean, what do we want to do? We want to build a smart contract, right? And let's just, I mean, write, before we build, we need to think of what we want to build. So what do we want to build today? We want to build a smart contract that allows people to maybe deposit Ethereum, for instance, right? That allows people to withdraw Ethereum, right? I mean, Ethereum in this sense is Sepolia Ethereum because it's the test Ethereum, right? It's a test network actually, right? The main Ethereum, you can see it on CoinGecko.com, right? So we're going to be building on test nets, right? It's just basically a test environment. So we're going to be having to withdraw Ethereum, right? Or let me just say Sepolia Ethereum to be much more specific. So Sepolia Ethereum, right? So we'd also want to, you know, just think of a file set as a place where you can um, get out, certain tokens. For instance, Sepolia Ethereum. Let me quickly show you an example. I think we went over one in our last class. How can I still remember? I think okay. Let me do this. Let me quickly go on Telegram and get the link there. Right. So okay. I'm a sports fan, so I support Chelsea. So that's why you can see this. So let's go to there's something I want to show you guys. Invisible. Okay, yeah. So let me just pick out something. Where is this link? I think I kept it here. Okay, yeah. Let me copy this. Copy link. And then thank you, you've done your console. So yeah, so let me copy and paste this. So this is a place where we can get this is a file set, right? Where we can get Sepolia Ethereum, right? So all I have to do, just like the last class, is to put in my wallet address here, right? So, before you can get your wallet address, you need to create your wallet, which we have gone over in our previous classes, right? So this is all I need to do. Copy my address here and then paste it here to receive Sepolia Ethereum. By the way, I've done this before. That was like last week. That's why I had, they gave me 0.05 Sepolia Ethereum, which I'm going to be using to build our own file set system or smart contract today, right? And I've been spending it on developing and stuff like that. That's how you can see that it's a bit reduced, right? So let's request another one because I think the last one we requested was last week. So I think you can withdraw just once a day, you get. So this is the file set basically. I think it's owned by yeah, it's owned by Google Cloud here. So it's basically a place where you can get Sepolia Ethereum for test purposes. I mean, you can see everything here. Zeta Chain testnet, Mantra, blah 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 blah. Everything was in here. It's a testnet token. Nobody would provide a place where you can get mainnet token because it comes at a cost. You get I mean, it's a real value, but yeah, Sepolia Ethereum is more like a dummy Ethereum, a place where you can deploy and test things. It will simulate like you're literally testing on the Ethereum mainnet, right? So yeah, this is a platform where you can get Ethereum Sepolia, right? So this is basically what we're going to be building, and all I have to do is to go to this site rather, and then enter my wallet address here and receive Sepolia. So you could see that, okay, it's processing my tokens, right? So it's pending, you can see here it's pending and there's a transaction hash already. So let's just wait until it's confirmed before we go check my wallet. So my wallet, I expect that's my, okay, I think it's confirmed now. So I expect that my address balance should increase. Exactly. So you can see it's just literally went from 0.04 to 0.09. So yeah, so that I mean that's been said, we have more than enough to build our own smart contract. So, like that's basically like what we just interacted with. We interacted with a smart contract, but in an interface, you get this literally. Where's that thing again? This is basically an interface here. I mean, they provided this interface for us to like abstract the need to communicate with the contracts probably directly, right? So underneath of this thing here, it's literally interacting with the smart contract. You get so they just abstracted, the smart contract with this interface, and all that we needed to do is just to select the network we want to request for, and then enter our wallet, right? So so yeah, what do we need to do? We need to deposit. Although we could not deposit in this one again because this one is just a smart contract where you can just get. You only have to just request for Ethereum or separately Ethereum, and you're going to be given as far as you have not requested for it that same day. So it's just like you can only request once a day. So yeah, in our own contract we can define our own terms. So yeah, we will require people to like, I mean, we will create a function for people to deposit Sepolia Ethereum, right? Or withdraw Sepolia Ethereum, right? So we are going to be interacting with two users, which is the user, like the normal users. Like I use this platform now, so uh, how do I let this go? Okay. So because I use this platform, I use it as a user, right? There's something called owner, which is the owner of the platform, you get. So, and that will be the person that deployed this contract, which is Google. You get probably one of Google's deployment wallets for Sepolia Ethereum. So we're having users, which is the normal users, and we're having owners as well. Okay, let me just come here. Owners, right? I mean owner. Owner is going to be basically owner, like the owner of the smart contracts, right? So so far we have listed out things that we're going to be going through. So, okay, we need to set a withdrawal amount, right? Or amount you can request. You can see just like here, the amount is fixed already, 0.05 Sepolia, right? So let's just set ours to, I mean, okay, let's just have withdrawal amount here. I mean, withdrawal amount, you get that we're going to set to maybe 0.001 or 0.002 or something, you get, so that we'll not run out of Sepolia. It's 0.001, for instance. So, um, okay, so having our withdrawal amount sets, not really set, we're just going through what we want to build so that by the time we start coding, we would, to create a guide for us, right? So, here now, if let me try something again. If I try to request again, right? Let me just do it again. If I try to request again, let me see. Okay, yeah. So it's telling me, each wallet gets one drip every day. Like I can only access it for once, like just once you get, so that you know the contract will not easily run out of Sepolia Ethereum if we're requesting for it over and over again. So let's also implement something like that too. So we're going to name it probably cool down time, maybe cool down time, like um the amount of probably we'll set it to 1 day basically, cool down time. So maybe um this is gonna be literally the amount of time or the day that you can request for Ethereum after you have requested for it last. So it's going to check. Basically, what this does is that it's going to check the time frame of when we last received the drop you get, and make sure that once we received it, we cannot receive it again in the space of 1 day. So I have to wait for the next day. So okay, so far we've had our deposits, our withdrawal. We have two types of users, which is normal users and the owner, and we have our deposit function, withdraw function. Okay, and cool down time. So I think because we're going to be creating something very simple, so I think we should just get started with this. So by the way, trust me, if I mean if you what's it called? If you um if you have coded before or everything code before, this will be very easy. You get. But if you haven't, I mean, it's gonna look somehow, but just stick through. And by the time you also go through the platform I'm going to refer you to learn about blockchain basics and how to write Solidity, it's going to be much more easier. You get. So so yeah, so the first thing we're going to do is to indicate that this is a what's it called? This is a contract, right? So we're going to write contracts, right? Then the name of the contract, which is faucets, right? And then we would enter our, what's it called? Our braces. Yeah, don't worry about it. Okay, I think this meeting will end in 10 minutes, right? So like I said earlier, when once it ends, please let's try and join back, right? So this is basically like synthesis of Solidity, right? If you're familiar with Java, you would understand this very well, or maybe JavaScript as well. You get even Python as well, so you would understand this. But if you're not, just just watch along and you know, just in your own convenience, take the course I'm going to refer you to. It's a free platform. You can literally learn anything about blockchain there. So it teaches you all this, right? So this is a place, just know that this is a place we're going to be writing our codes, right? So um we need to, indicate that it's a contract, and we've done that. Right. The next thing is that we're going to tell Remix the version of Solidity we're going to be using. So in this case, we're going to be using 0.8.20, for instance. No, 29 is not how it's 0.20. So let me do this. Yeah. So um so the next thing in line we're gonna do is because we already listed out something already. So let's follow this guide here. You can see that they're in comments basically. How do we comment things? We just put this line like this two times and then we write things there. So the compiler will not read this as a code, rather it's gonna be a comment, like so that just like how to take notes when writing a code. So, but the compiler means, you know, what's it called? The compiler is basically a virtual machine that translates the code for writing into the codes that the computer will understand, like the virtual machine will understand, basically, right? So yeah, you can see the things for writing is in basic, English, like contract file set. Basically, this is just telling us that this is a contract named file set, right? So let's continue. So because in what's it called, in blockchain, yeah, one of the ways we access our blockchain, I mean, one of the ways to access blockchain is via a wallet address, right? So addresses are very important. So now for every user that wants to use our platform, they would identify as an address. You get, because you know that in Web3, I mean, they don't need to know who you are except you go through KYC platforms. I mean, platforms that require you to have your KYC. But this, since we're using our Sepolia, I mean, it's not building a basic file set. All we just need is to just know the address that's interacting with our contract. So we're going to say address, then we're going to put a public modifier, which is going to be a public. The access modifier is like, the things that how do I say this? So there's public, there's private. So public is that, okay, everybody can see this, like everybody can see. Then private is that, okay, only some select number of, contract or people can see it. But by the way, when you go through the course, you understand this. So let's just, set our owner. Since our owner is going to be an address, right? Then we're going to we have two types of users, which is the owner, and then we'll create on that kind of user, right? Which would be the normal user, right? No, sorry, we do not need this. We do not need this. I will show you why. Um, so we only need our owner, right? So, I mean, we really need to set our owner, right? So, let's set the so far I've set the owner, right? Okay, now let's now code the cooldown time, right? So this is gonna be an on-site integer 256. So this is like an integer, right? That takes a very, very large amount of numbers from zero to almost infinity, but not infinity. It's a very, very long number. I mean, more than trillions, more than what's after trillion? It's more than it, right? So it can hold a very, almost infinite amount of numbers from zero to literally the end of U into 256, which is like this kind of number. For instance, I mean, it's more than this, but then you cannot even read this because billions, I mean, billions is like nine figures, trillions is 12 figures, 15 figures, blah, blah, blah. You can see this is, I can't even count this here. So this is just creative, I mean, almost infinite, but at least it creates, you know, a way that, I mean, it creates, what's it called? Numbers from zero to almost the end of, not really the end of numbers because it's not infinite, but what I'm trying to say is that there's no how we want to all the numbers you can possibly think of here, it can contain it basically. That's what I'm trying to say. So that's why we use U int 256 to hold numbers, right? So coming. So yeah, so because we are setting things that we need in our smart contracts, right? So we're just going to be public as well. Then we would set it as cool down time, which will be equal to 1 day, and see 1 day. So just, this is just trying to say the cooldown time is going to be set to 1 day, right? And this is trying to say, okay, this is the owner, and the owner is an address, right? So I think the next thing we're going to need is we're going to set a withdrawal amount, just like how this guy set the withdrawal amount to be 0.05, right? So let's set our withdrawal amount to be, because we're dealing with numbers as well, so we'll set it to a int 256, but dealing with positive integers. Public withdrawal amount, withdrawal amount, it should be equal to, so I said we're going to set our one to, okay, 0.001. Yeah, so that we will not run out of this thing. What's it called? So we have to set it to Ether, right? Because we're dealing with sepolar Ethereum, which is like a type of Ethereum, right? So we're going to indicate it as Ether, right? So, okay, I think one of the ways we can, so let us write a comment for us to know what this is. Right, so this is the amount users can withdraw, you get, right? And this is, this is just simply saying that, okay, users can uh, withdraw once per day. Yeah, withdraw once in a day or per day, right? And this is the address of the owner of the smart contracts. So comment is a way to, make your code readable and make other people, developers and even people that are reading the code to understand what you're trying to do. So, so the next thing we're going to do is we're going to, you know, um, what's it called? So let's say, how did this guy know that, that the next time I'm going to be able to withdraw is going to be, February 17th of 2025, which will be tomorrow by 4:21 p.m. So how did he know? It means that it's keeping record of, other than it's keeping record of last withdrawal time, right? So let's also set that as well. So rather than, having to set the last withdrawal time like this, right? Just like having to write over last withdrawal time, then the time, what we're going to do, we're going to be mapping the address that received Ethereum, the address, we're going to be mapping it to a number, right? U int 256. So we're going to be using 256 during the course of this thing. Then we're going to indicate it as public, and we're going to set it as last withdrawal time or last withdrawal. So it's basically just indicating the time that we last withdraw, you get. So I mean, this would not be familiar because it's not like this one. So this is literally just saying that it is taking in this address and returning this time. Basically, that's just what it's saying. Again, when we when we go through the Cypher object course, we're going to understand all this. So this is just basically synthesis of Solidity, right? So in Solidity, there's something we call events. Events is like how to, like in JavaScript, we call it console.log, right? In Java, what do we even call it in Java itself? Public syntax or something like that. I don't forget. I used to be, I used to be, I used to be, what's it called? A backend developer. I used to work at a fintech company in Lagos then until I came into Web3. So we used to use Java then.